Dear teachers and students, till now we have understood the effect of roughness on friction, and before that we also understood the meaning or concept of static friction. Now let's go a little further and talk about another factor that would or would not affect the frictional force. Now observe carefully. I have this block that we have used last time. Look at these two contact surfaces. This is surface 1 with wider area. See, you can see lot of area. Whereas this is surface 2 with less contact area. In the first experiment or sub-experiment, we are going to pull this block with the help of the spring balance with more contact area touching the surface. So we'll be pulling it. And in the second scenario, we will keep it upside down. That means the smaller contact area will be touching the surface and will again pull with the spring balance. Can you make a prediction? Where do you think more frictional force will be there? Or in other words, where do you think I have to apply more force to move the object? With more contact area or with less contact area? So I think I can hear your mind voice. I'm guessing that you feel more contact area would require more force, whereas less contact area would require less force. The logic behind this guess or this prediction is, since there is more contact area, there are more number of irregularities, whereas with less contact area, there are less number of irregularities. So you are guessing that since less irregularities are there, it's easy to pull them, less obstructions. Let's complete the experiment. We'll record the results, and after results, we will see if your prediction is correct or wrong. If it is correct, fine. So your hypothesis is correct and you achieved your goal. If it is wrong, that's where more learning will happen. We have to understand clearly why it went wrong. Your prediction, why is it wrong? Is there some other factor that is affecting other than the number of irregularities? That's what we have to explore. Okay. Before we start, please look at the board for the observation table. Spring balance reading with more contact area. Spring balance reading with less contact area. That's it. These two readings you have to write. So let's get started and observe the experiment. Now, this is the same arrangement as before. Our spring balance with a thread, and we have a block and we have some weights on top of it. And observe carefully, we are using more contact area first on this table. So let's check the maximum frictional force or the limiting frictional force. I'm again pulling. I can use the holder and pull, but I'm using this spring balance in this way. Now as you can see, the block has not moved. Always make sure it is moving horizontally. So it's 1 Newton, it's 1.5. I saw the movement around 1.5 Newton. Let me repeat so that we have consistency in results. Now this is 1 Newton, there is no movement. Somewhere between 1.3 and 1.5 Newtons, I am seeing the movement. That means spring balance reading with large contact area is somewhere between 1.3 Newton to 1.5 Newton. Now let's reverse this so that we can use smaller contact area. Same experiment, arrangement is the same spring balance, everything is same except the contact area. Now according to your guess, less number of irregularities are touching because the contact area is smaller. As you can see, it's very small compared to the previous case. I'm going to pull the spring balance in the same way and I'll read out the results. So that's 50, that's 100. Let me repeat. That's 100. And again, I'm seeing approximately at the same thing, somewhere between 1.3 and 1.5. I want to place it at a new location for consistency. Now that's 1 Newton. Again, exactly at 1.5 Newton, it started to move, or around 1.3 to 1.5. So I hope you appreciate what just happened. With more contact area and with less contact area, we are getting the same result. That means it's not just the number of more irregularities or less irregularities. There is some other factor that is affecting this result. So in a way, Frictional force does not depend on the contact area. Is it more or less? It's not important. You are getting the same spring balance reading. Now we'll go ahead to our board and try to understand why we are seeing the same result. Let's see the results on the board. We already have performed it. With more contact area, we saw somewhere between 1.3 to 1.5 newtons, and with less contact area too, we saw the same thing, 1.3 to 1.5 newtons. So what is the conclusion from this experiment? Frictional force remains the same even when area is changed. That means contact area does not affect the frictional force. Let's try to understand in a deeper way. For that, we have to consider one more factor. When we predicted before, we were only considering the number of irregularities. But there is another factor, people, the depth of interlocking. Here, number of irregularities is more, number of irregularities is less. We completely agree to that. But what is the other factor? How deep the interlocking is happening. Now, think about this carefully. Now, this entire weight I am placing on my hand. When I place it on my hand, the entire weight is given on a large contact area. Since it is given on a large contact area, the pressure that this block is subjecting on my hand, or the pressure that is applied on my hand, is less. Or in other words, this block is not going deeper. But if I do the same thing in reverse, see, now this time it is less contact area. That means this time there is more pressure as area is smaller. It goes way more deeper. So even though the number of irregularities are less, they are going deeper to make a greater interlocking. Here number of irregularities are more, but they are not going deeper. They are just touching the surface. It's very simple to understand. Imagine you have a pencil and you are applying force on your finger. So try to think of same amount of force. When you have more area and you are applying certain amount of force, it doesn't go deeper. But when you have less area and when you are applying the same amount of force, it goes deeper. So that is the reason a sharp nail can be easily passed into a wall. Okay, the same concept is happening over here. Let's summarize it with our results. The first column for ours is, as usual, this time it is area of contact. Second column is number of irregularities or ups and downs. Third column is depth of interlocking. And last one, frictional force. Alright, the first one is large contact area and second one is small contact area. Now let's think about number of irregularities. As you already know, since there is more surface, more number of ups and downs will be there for large contact area, whereas here less contact area, so less number of ups and downs. Now, where is more depth of interlocking? As we already have established, since the surface is more, the pressure is less and it does not go deep into the surface. That means the interlocking depth will be very shallow or less. Whereas when we use the smaller area, it presses much more hard on the surface due to high pressure. Less area, more pressure. More pressure will be there. So the depth of interlocking will be deeper. So here we have less depth of interlocking. Here more depth of interlocking. Observe this. More irregularities but less depth of interlocking. Less number of irregularities but more depth of interlocking. Because of this we have a cancelling effect. What I mean by that is, imagine you want to buy certain number of chocolates or you have certain amount of money. Okay, so let's say you have 100 rupees. With 100 rupees, let's say you are buying 5 chocolates, and that means each chocolate cost is 20 rupees. Okay, Let me try the reverse way because I want it more and less. Okay. Now, each chocolate cost is 20 rupees and you are only buying 5 chocolates. So when you multiply both of them, you are getting 100 rupees. Now, let's think about the reverse. You are using the same 100 rupees, but what is happening over here? You are buying, let's say, each chocolate cost is only 5 rupees. But since it is 5 rupees, the number of chocolates would be 20 rupees. So what is 5 times 20? It's 100. So more, less, less, more. End result is approximately the same. That's why frictional force in both cases would be equal, or in our scientific way, frictional force does not depend on the area of contact. This is applicable only in macro scale. If you make the area smaller and smaller and smaller, then you have atomic forces acting and your results would not be according to the macro scale. But let's stop with our macro scale right now and we'll proceed to another activity. Thank you.